Hey guys, today's video is all about the different ways that we can look at a function, the different ways we can represent a function. And it's really more of a conceptual video today. There's not a lot of math problems to actually work out, but it's something you definitely need to be you need to be paying very close attention to, because some of these ideas that I'm going to talk about are a little bit abstract, okay? So they're a little bit tough to grasp sometimes. Our objective is I can represent functions in several different ways. We are going to have the page number is 42. Today's date is November 12th, 2013. Make sure you are correctly recording the page number and the date. And our objective for the day is I can represent functions in several different ways. There's actually 4 different ways that I care about. All right? 4 different key ways. Hang on. Sorry about that. 4 different key ways to represent a function. And those 4 ways are verbal, algebraic, numerical, and graphical. And you're already familiar with most of these. You're just not used to looking at them in the way that I'm going to talk to you about. So, the verbal model for showing a function. This is what you see when you first are exposed to functions in school. And this actually happens way back in elementary school. A teacher might say something like, multiply by 2 and add 4. That is a verbal representation of a function. It tells you a rule that you apply to any input. So you have an input that goes in, then you multiply it by 2, add 4, and that's when you have your output. You should be writing these down, okay, including the little notes that I put. I find that people aren't adding the notes that I'm writing, and you definitely need to do that. The second way we can look at a function is algebraically, using algebra. Algebra is all about variables, and an algebraic representation of a function is simply an equation. This is the most common way you're going to see a function. It's also the most concise. Concise means short, okay? It gives you a lot of information in just a little bit. For example, 2x plus 6. That is a very short description of a rule that says multiply your input by 2 and then add 6. So we like algebraic representations of functions because they're little, they're small, they're easy to work with. It's the most powerful. It says that they're the most powerful representation because you can get a lot of information from an algebraic representation of a function. You can get something called the slope, which we're going to be dealing with next week. You can get the y-intercept of the function. You can anticipate what the graph of the function is going to look like just by looking at the function itself. The input, when you're writing a function algebraically, is going to be your variable. Your input is going to be your x. You usually see this written f of x equals 2x plus 6. The function of x, which is our input, equals 2 times the input plus 6. A third way to look at a function is numerically, okay? And there's several different ways to show it numerically. But you could have a list of ordered pairs like 0, 1, 3, 4, and 8, 10. That would be one numerical representation of a function. A list of value pairs, you can recognize this as the x, y points that are used in graphing. So you go over 0, up 1, over 3, up 4. You might also see a numerical representation shown as an XY table, which you guys should be pretty good at finding at this point after the work we've been doing this week. So you'll have your x's and your y's, and you'll have a table showing what the rule is. So 0, 1, 3, 4, and 8, 10. The final way to look at a function, to represent a function, is with a graph. A graph is just a visual representation of a relationship. So you might have the x-axis is distance and the y-axis is time, and your graph gives you an idea of what the relationship is between distance and time. If the line goes up really, 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 really steeply, you know that you're going a short distance, or sorry, you're going a great distance. I totally messed that up. I switched my D and my T. Sorry, guys. This should be T, and this should be D. In just a very short period of time, you're going a really high distance, so you must be going very, very fast. You can learn a lot about a situation by the graph of the function relationship. All right, oh, hang on. That's weird. All right, so those are the 4 different ways that we can look at a function. You need to be comfortable taking a function and showing it in all 4 of these ways. On the next page, we're going to look at some examples with a real function. We'll call this function function A, and we'll look at it first as a verbal representation. I'm going to put a little V here for verbal. And so we have Jay earns $2 for every lawn he mows in a day, but has to spend $4 on gas. All right? So a verbal description explains a relationship between mowing lawns and how much money that Jay has. If we then write that algebraically, we can see the relationship between this equation and the verbal description. We have 2 right here, $2 for every hour, sorry, for every lawn he mows. So what does my X represent? X represents the number of lawns, and he gets $2 for each lawn. Then I have -4, and that -4 represents how much he spent on gas. So you can see the connections here between the verbal expression and the algebraic expression. We can then create a table based on this function. So let's choose a value of -1 for x. We can do 2 times -1 minus 4. That gives me -2. Ooh, hang on. Weird. My computer is being very slow today. That leaves us with -2 minus 4. Change subtraction to adding the opposite, and we get -6. You can do the same thing when you put 0 in for x, and you would get -4. And then you can put, say, 1 in for x, and get the value of -2. So this is a numerical representation of our function. We have an XY table that shows the different ordered pairs. So we have -1, -6, we have 0, -4, and we have 1, -2. If we then take that and turn it into a graphical representation, we're going to plot our different points from our XY table. So we're going to go left 1 for my first ordered pair, and then down 6, 4, 5, 6, right there. We have 0, -4, which is going to be right there, and we have 1, -2. So when we connect these dots in a line, let me just adjust that a little bit. There you go. You can see what the graph of this function looks like, and there's some really interesting things you can find from the graph of this function. For example, you can see where the graph crosses my x-axis, okay? And it crosses the x-axis at 3. This represents, sorry guys, a student came in to say hello to me, and so I forget where I left off. I apologize. And actually I have to adjust this graph just a little bit because it was off a bit. All right, so if I look at this red dot, right about there, I can see that my graph crosses the x-axis right about at x equals 2. When x equals 2, y is going to equal 0. What does that actually mean to me, though? Why does that matter? Well, it matters because if y here represents how much money Jay earns, this tells me that he has to mow at least 2 lawns before he breaks even for the day, before he ends up with zero as far as the money that he earns. And you can see as he mows more lawns, the amount of money he makes gets even higher. But what if he only mows one lawn? Well, he's still going to spend $4 on gas, and so he's going to have a negative profit. These kind of graphs can give you a lot of information that you might not necessarily get from a verbal description, an algebraic description, or a table of numbers, a numerical description. As you can see, every single kind of representation of a function has a very, very different purpose. It has a different job. So as we move on through this function unit, we're sometimes going to be using verbal description, sometimes using graphical description, sometimes using the other two. And we're going to be trying to figure out what representation of a function is best for whatever job I'm trying to do. Okay? For your reflection question, I want you to simply describe in words what's different about these two functions. We'll call this one function A, and we'll call this one function B. Just describe in as many ways as you can how function A is different from function B. Okay? Thanks, guys. I'll see you tomorrow in class.